In section 5.1, number 35, we need to verify this equation is an identity. The right side looks quite simple, sine of x, so I'm going to start with the left side. I'm going to write the tips as we go here. So the first, let's do some little tips over here. It kind of helps to have these in our tool belt of things to think about, to do when we're not quite sure what to do. So the first thing, if you're kind of looking at this like it doesn't jump out what to do, first thing is try to simplify the more complex side. So in this, remember, we're working only on one side at a time, and in this case the left side looks more complicated. So I'm going to work just from the left side. And usually I would just abbreviate that LS, just to remind myself what side I'm working at. So working with just this side right here, the next thing I'm going to do to try to break this down is, well, when I break this down to sines and cosines, it does a couple things. One, it makes it more familiar to me so I can see relationships faster and I'm more comfortable with it. But also, we have those fantastic Pythagorean theorems that make things squared, and they also make things go away and turn into 1, which is always lovely. So I'm going to, and also on the right-hand side of this equation, I want sine in the long run. So I want all of this to turn into sine, so I might as well convert everything to cosine to sine now. So I'm going to convert, or I should say express, all terms in terms of cosine and sine, right? Secant, cosecant, tan, cotan, all those things I can convert into terms of cosine and sine. So the first would be the secant is 1 over cosine because they are inverses of each other. And cotangent is cosine over sine. And tangent is sine over cosine. Okay, now my numerator looks pretty simplified. So let's work in the denominator again. So this is kind of like working on the more complex side, try to break it down. So this kind of goes back to step 1 or tip 1. And for this one, I'm going to use I'm going to add those fractions together, try to get one fraction out of it. So to do that, we have this formula, which is really just adding fractions together and finding the common denominator. So I'm going to apply that to the numerator here. So I'm going to copy the numerator, I'm going to apply it to the denominator. The numerator I'm just going to copy down. I'm not going to do anything to that for right now. And the denominator, I'm going to add it together. I forgot what color we're using here. So for A is going to be cosine of x, and B is sine of x, C is sine of x, and D is cosine of x. When I add those together, I get cosine x squared plus sine x squared over sine x times cosine x. And just as I kind of was hinting at the beginning, when we turn things into sines and cosines, often things just kind of go and turn into 1 because we get to the Pythagorean theorem, which is really helpful. So, and we have that here. So I can actually change that into 1. So this is just 1. So that is using the Pythagorean theorem identity function of so our tip there is to use identities, and our example here is specifically we have the Pythagorean theorem. So this thing turns into 1, which makes this much simpler. So let's copy this down. Now what we have now is 1 over cosine, and on the denominator we have 1 over sine x times cosine x. Let's turn this into a division problem. I have a big division bar right here dividing these fractions, and so let's rewrite that as a division problem so I can see what happens to all these parts. So if I'm going to do 1 over cosine divided by 1 over sine of x times cosine of x. And when I flip the second and multiply, oops, I forgot my x there. I find that my cosines will cancel when I multiply these, and I'm left with just sine of x over 1, or sine of x, which is what is on our right side. On our right side we have sine of x. That was our end game goal, and we have reached it. So this one is done, because the left side now equals the right side.